So now we'll go to our internet settings, go to our Ethernet, network and sharing, this Ethernet, go to our properties, version 4, we're going to the service port 169.254.1.1 is the controller, so we need to be at least one off, so we'll do .2. Make sure you press OK and close everything. Go to our Internet Explorer, any type of internet is fine, and we type in the controller. And now we're in. If we want to change the factory port, we can go into our settings, network, edit, and we can type in the IP address that we'd like, and this would have to be set through manual. Next thing we typically do is go back into settings. We can go to our preferences, and we can pick our torque units. So for this, we'll change it to inch-pounds. We can make sure our time is correct. Then we can also, typically we change, it comes as Celsius, we can change it to Fahrenheit. The next thing we'll need to do if we are connecting any battery tools is we'll need to turn on or off the Wi-Fi or Bluetooth, whichever type of tooling that you selected with your purchase. Now we'll quickly review the pairing process of a Atlas Copco battery tool. First, hold the trigger down on the tool, then put on the battery. See, the lights will turn on. Let go, the yellow lights. When the lights turn back on, you hold the trigger again. Let go. And you can do it for the third time, the lights will turn on. Hold the trigger down, then it'll go into pairing mode. Once we have the tool in pairing mode, we want to make sure we go to settings and ensure that our Bluetooth or wireless setting is active. We can then go to the tool icon and go to the pairing mode up on the top right. Here it will give us instructions whether we're connecting an STB battery tool or an ST wrench. We are doing an STB in Bluetooth mode. We hit that, and now the controller is searching for the tool through the Bluetooth process. You want to make sure that the tool is still flashing the yellow lights to ensure that it is in the pairing process. All the LED lights on the tool will turn on. Pairing process shown on the controller, and the tool now has a blue LED showing the tool is connected. And now here is our tool with all of our information. You may need to do a motor tuning if it is the first time that the tool is connected to this controller, or possibly that it came back from a software update. You may need to do this motor tuning. From here, we'll go to our virtual station. We'll change the name of this to VS1. Just to show a difference. And we'll show our tool here is our STB tool that we saw before, same serial number. Since the blue highlight is around this tool, we know that it is currently configured to this virtual station. We know that it's selected, and this is the virtual station it's connected to. Now we'll want to go to our virtual station 1. We know it's licensed, the tool is active and connected, and we have a task of a batch sequence. We want to change that to a tightening program. Tet L. We'll now go over here, and we'll be able to see that the virtual station 1 is active. Now we'll quickly go over setting up a tightening program. The best way to do this is to look at a previously run trace or run a new trace and look at those results. So we'll go to our reports, we'll go to our last OK here. See, this was the last result that we got. It was the TED-L program up top here. We'll go into the different traces. So this is torque over time, and this is torque over angle. So we'll see that this is a nice machined machined screw here, so there's no prevailing torque going on. So we can set our rundown complete of around 5. When we go up here a little bit, so this is when the bottom of the bolt head touches the surface. We'll go up for our next torque, our first torque of about 15, and then our final torque we will keep at 44. So this is the TED-L program, a quick step with a target of 44. We'll go to our tightening parameters. So in our first stage here, we have a soft start is on. We're going to go 35 RPMs for 90 degrees of rotation, and the max torque on this will be 11. So we'll be allowed to go up to 11. That's going to be too high for this process. That would essentially show a cross thread. So we'll bring it down to 3 inch-pounds. Is going to be our max torque on this first step. Stage 2 here is our rundown stage, so we want to go fast. We'll change the rundown speed. We'll do it here. We'll go 200 RPMs, and you'll see if we scroll down, our rundown complete torque was 26. So from the trace that we just saw, we want to change that to 5 inch-pounds. Of course, you can see there's several different settings that we have within the rundown stage, but we'll just go through a quick program here. And the new software will apply those changes. And step number 3, which is our tightening stage. Again, we have our quick step, our first step target. So after our rundown complete, at this point here, we're going to go up to another torque at a certain speed, which is our first step here. So we said from looking at the trace, we'll go to 15. And we'll change the speed here a little bit. We'll go down to 75 RPMs. So we'll go from this point here, from 2 up to 3 first step. And then we'll do our final step. Our final torque, which is 44. Our speeds, we'll want to go slow, 25. That's good. Let's go down to 20 to change it. And then we'll also have our torque limits. So we'll say the lowest torque we can get is 42, and the max is 46. If it falls outside of those ranges, then we will get a NOK and a red light on the tool. Number 4 is a soft stop. If we want to enable or disable that, we have this as standard, it's off. Apply those changes. Now I'll go and do a rundown with this tool. We got a final result of 44.2. There's ways to check this directly on this screen as well, but since I'm using the Surface Pro, it's easiest to go to the reports, go to our latest results, and you could see this populated here. This was actually the loosening that I did, and then this was the tightening. We'll see that those settings were put in and seen. We had a rundown complete. If this is the 6 mark, it was just under 6. Then we had our first torque around here, which was 15. And then we had our final torque, as you could see from the top, it was 44. So you could see these settings were put in. We went from small target torques like our rundown complete up to our first target. Again, we went fast for our rundown. We went slow to our first torque. It was at 75 RPMs, and then very slow to our final torque to make sure we got the proper clamp load. We only went 25 RPMs. You can see if we were to get a spike in our first stage here as well, we would have failed due to if there was any cross-threading. If we went over 3, which we did not, we would have failed. This was a okay, proper tightening. You could see we changed some of the settings from before, and those were applied and shown in this trace. So what I just did is add a new tool to the controller that's connected, and I also added a new tightening program. So if we go to our tool now, we'll see that there's now 2 different tools connected, a ETV, which is a right angle tool, and the existing ETP that was paired before. We'll now go into our virtual station, and we'll see that we only have one virtual station. So we'll need to add a new one for the new tool that was added. And we'll call it VS2, Virtual Station 2. We'll have to do the critical control license. Our tool config, this is the next tool that's available. This is our right angle tool. And we'll change its task to be angle only. Now see the 2 different tools. We'll back this one out. We'll see the rotation. Also, just to show, this tool here is now spinning. So we're doing 2 tools at once, getting results on both of those. $44.1. We see here is 721 because this one was angle only. We can now see through our reports, we had Virtual Station 2, got a result of 721. Virtual Station 1 got a result of 44.1. If we wanted to, we can look in here as well and go through and see the different traces. You can see Virtual Station 2 had the tightening program of angle only. Virtual Station 2 has a tightening program of angle only.